So my name is Spencer Jobe, and I'm going to be talking to you today about using HTML and CSS selectors as a data interchange format. So these are some data interchange formats that we know and love, possibly hate. XML, JSON. I got these examples from W3 Schools, and they're pretty basic. You know, you got your employees, first name, last name. Everything's nice. We know we access them through various modes of JavaScript. But you know, what happens if you have 19,000 employees? More specifically, what happens if your data set is really big? So this is what I did. I took a CSV file that had 19,246 records. Each record had 42 data points, which totaled 808,332 data points altogether. It was a 3.5 meg file. I downloaded it from bls.gov, and it represents employment and wage data for every area. So that's every state, county, and metropolitan area in the United States. Figured that'd be a pretty big data set that we could use. So was XML performant? Well, what do you think? No. What about JSON? Was it performant? Well, sticking with the traditional JSON format, I ended up with a 27.6 megabyte file. Fail. But as it turns out, the numbers don't lie. If you're clever with JSON, you can actually get it to be much more performant. And we'll cover a little bit more on this later. So my goal was to quickly access the data based on some of the key fields. You can think of these as your primary and secondary keys in the table. And in this particular file, we had a 2-digit state code. In this case, 26 represents Michigan. And we had an aggregation code. 70 means the county level. And there are various other aggregations. So this is what I did. I took the CSV record, and I wrapped it in a paragraph element. And I took out the primary keys and added them as CSS classes in each paragraph tag. I know what you're thinking. It's crazy, right? Well, it gets worse. So to access it, it's actually quite simple. You create a div element, and we're not talking about any of the render tree here, so it's actually quite performant. You take the response text, which represents a giant blob of paragraph tags, and you just insert that into the inner HTML of your parent div. After that, you can use query selector all, and you can mix and match whatever keys you want to get out your records. Oh yeah, and I got rid of the eval thing. I don't know if you guys saw that. So down there at the bottom, it might be hard to see for those in the back, but if you use eval, you can take a string that represents comma-separated values. You can encase that string in square brackets, and then just pipe it through eval, and you'll get an array. It's a quick way to actually parse CSV data. But I didn't want to use eval, so I wrote a function. It was a little bit more performant. Did it work? Well, I ran some tests. And this is essentially what I got. So for each one of these tests, I ran them 31 times. And the goal was to load the 19,000 or so records into memory and then pull out Michigan counties, Michigan state code being 26 and ag level 70 being county. So it was only 84 records in a 19,000 record subset. And these were the average times that I got. And you can see that the file sizes kind of go off the rails when you get down to XML. That top line there, the CSV JSON, is the little caveat. So it turns out if you take a CSV file and you smush it into a series of arrays, like I've got down there at the bottom, and you just have one property in your JSON object, that you can actually parse that with JSON.parse and loop through all the records, pulling out the fields that you need based on whatever fields it is that you're looking at. And so the downside is that your filter code ends up being this kind of nested if statement. You know, if it's Michigan, OK. If it's a county, OK. And so you'd have to write that over and over again. The benefit you get with HTML as your interchange format is that you can use the CSS selectors, which allow you to kind of mix and match based on what you want. So this is all run over the local host. Obviously, I didn't want to introduce any network traffic here. Or speed. So that's essentially what these numbers are. So on average, the CSV JSON format took about 0.6 seconds to run through those 19,000 records and pull out the 84 that I wanted. HTML was a little bit higher at 0.67 seconds. And the CSV there in the middle, that was kind of like the anti-format. So instead of conforming to XML or JSON or the weird JSON or even HTML, I said, what if you just pipe the CSV, just byte for byte? Here it is. The response text is the CSV. And then you run it through that eval loop. And that was the smallest file size, but it actually took a little bit longer because you had to run eval on all of those things. If you have your data stored as CSV records encased in paragraph tags with those classes, you don't actually have to parse each one of those records. You can use the CSS classes, use your query selector all, pull out the things you want, and only then execute the parse. If you have hundreds of thousands of records, you can quickly grab the subset that you want without actually having to process every record. So yeah, that's my talk. Those are all the data points, just to let you know I did actually run them. Yeah, so that's it. Any questions? Do we have time for questions?
How did you get this idea to do this?
I work with a lot of big data. And a lot of times what makes something interesting like a map is having all that data. And so you can either render the map on the server and just pipe it back, or you can send a big chunk of data to the client and let them massage the values how they want. And so that was kind of the thrust for all of this, is see how quickly can you actually deliver data and then also make it performant in terms of pulling out what you want. So,
Thanks.
Yeah, you're welcome. Anybody else? All right, thanks.